안녕하세요. 윤준영 교수님의 정밀생산 메카트로닉스 연구실 장우선이라고 합니다. 그럼 발표 시작하겠습니다. Semiconductor industry, contact-sensitive objects undergo two major problems, which are contamination and structural damage. These problems can be solved by contactless object handling. Other than magnetic force, which cannot directly levitate non-ferromagnetic material, in this paper they're dealing with electrostatic levitation, which also allow to levitate not only conducting materials, but also semiconductors and dielectrics. The handling process in industries are usually automated using robots, but still human handling is often required, and in this paper they adopted a concept in which non-contact levitation techniques are combined with a haptic device. Now let me explain the concept of electrostatic levitation. An attractive force can be generated by creating an electric field between the object and the electrodes. Since the overlapping area is large compared to the air gap, the capacitance and the force can be represented as the following formula. As the electrostatic force is inversely proportional to the square of the air gap, active feedback control is necessary, and the control voltage evenly distributed to the positive and negative electrodes create the net potential of the object to be zero and no charge accumulation occurs. Also, the force equation can be linearized around the operating points, where it is clear that by controlling the voltages applied to the electrodes, the air gap between the object and the electrodes can be regulated. The disk in the figure has 6 degrees of freedom, of which only 3 of them need active control. The lateral translation motions of the disk have a passive restriction as a result of the active vertical control. In the center of each electrode, there is a hole through which a displacement sensor can measure the local air gap, and the coordinate system can be converted into one order by using a transformation matrix. The voltage that is sent to each electrode is a combination of the control voltage and a bias voltage, evenly distributed in 2 positive and 2 negative voltages. It is possible to realize that stable levitation of the disk with only proportional control is possible, as there is a natural damping effect present from the air. And an example of levitation only by proportional control is given in the figure, where with a feedback gain of 16 megavolt per meter and a reference gap of 310 micrometers for each electrode. And this graph shows that stable levitation is achieved. In a pick-and-place task, especially placing is difficult, and to make it more easy, an integrator in the controller is used, and the reason is typically to converge the system to a certain state, such as to a given reference position, or a state where the electrode voltages are exactly the bias voltages. So at the moment of contact at the desired location, a position error is forced resulting from a smaller air gap, and an integrator in the controller will make a control effort to restore the state of the disk grow exponentially with time, and after some time the levitator is moved up again, the resultant force on the disk is still downward, and through this process an automatic release is possible without switching off the control loop manually. There are two types of controllers regarding an integrator in a control. They are decentralized and centralized control. In the case of decentralized control, the controllers K1 to K4 in the figure should be identical. Other than the PD control, when an integrator is added, the system will become unstable since the 3 degrees of freedom are controlled by 4 controllers. So 4 perfect identical electrodes and sensor combinations should be achieved, or else an error will be increased by the integrator. It can be seen that the controller is unable to bring each air gap for each electrode to the desired position. So as a result, the integrator and the position error increases the control voltage for each electrode, and the positive and negative voltages are no longer distributed evenly. In centralized control, there are only 3 controllers to control all the 3 degrees of freedom. The number of electrodes and sensors are unchanged, and only a transformation on the position signals is performed as shown in the figure. To transform the control voltages in correct electrode voltages, a similar inverse transformation has to be performed. And in this case, the voltage is equally distributed over the 4 electrodes for vertical motion, and 2 electrodes are utilized for the 2 rotational motions. There's now no longer the problems encountered at the decentralized control. So when the integrator is switched on, the central position of the disk will converge to the desired reference position without continuous increasing of the electrode voltages. Now for the experiment is as follows. In order to pick up the hard disk, only PD control is used to prevent the unwanted voltage windup from the integrator. The linear motor will move down until it reaches the 0.1 mm position, where the air gap would be around 350 micrometer. The control voltage is only switched on automatically the moment the disk comes into the sensing range. The linear motor moves down while the disk is at the desired reference air gap controlled by a PID controller. From the moment of contact, a position error of about 16 micrometer is forced as the linear motor stays at its zero position. If there was only PD control, the control voltages would remain constant during this holding time as they are directly proportional to the air gap error. But with a PID controller, the integrator will reduce the control voltages with time. So even when the linear motor moves up again and the air gap increases again, it takes time for the controller to recover stable levitation, and it is unable to re-levitate the disk. As a result, the disk remains on the media adjustment screws and placing becomes successful. In this paper, the object handling task of pick up and place with electrostatic levitation have been discussed. And for the future work, it should be replacing the linear motor by a haptic device and performing pick and place task by human operators. That's all I've got for the presentation, and thank you for listening.